So I'd like to look at some background concepts for probability before we get into the probability distributions external. So a lot of this will be familiar to you from previous years. A lot of it we did cover specifically in year 12 in the probability external. And yeah, we'll just build on that and remind you of these facts. So first one I want to go over is that the total probability is 1, right? So probabilities can be written as decimals or percentages, and 1 means 100%. So probability that anything will happen is 1, meaning that there's a 100% chance that anything at all will happen. So if you're looking at event A or B or not A or B or pretty much anything within the sample space, all of it adds up to 1. And that can be helpful for us when we're dealing with complementary events. So complementary events are situations where they complement each other, kind of like black and white, but what they're complementing is that they'll add up to 1. So the probability of complementary events adds to 1. And some notation to remind yourself of is if I write something like this, that means the probability of A. So the probability of A plus the probability of B would be equal to 1. These would be complementary. So examples of complementary events could be that you're dead or alive. There's really nothing else as an option there. You're either dead or you're alive, and so the probability of you being dead plus the probability of being alive would be 1. That one of those things has to be true. Another example would be the probability of getting a 6 or not getting a 6 when you roll a fair dice, being complementary events. And so this can be written out for us in this way. The probability of getting a 6, well, on a 6-sided dice, there's one chance in 6 that you're going to get a 6, so it's 1 out of 6. And then we would write this, the probability of 6 not. So this means not 6. So anything but a 6. And the probability of that happening, well, you could get a 1 or a 2 or a 3 or a 4 or a 5. That's 5 out of the 6 options. And you'll notice here that the probability of 6 plus the probability of not 6, 1/6 plus 5/6 adds up to 6 over 6 is equal to 1. So they are complementary events. And just to show this diagram real quick, the yellow part, this is the probability of not A. And then inside the circle is the probability of A, the white part. And these are complementary because they add up to 1. So the probability here of A plus the probability of not A, or anything but A, will equal 1 because they're complementary. Here we've got an example. A and B are complementary events. So if the probability of A is 0.3, what is the probability of B? Well, if we think about this, knowing that they're complementary events, they have to add up to 1. So you could write it out for yourself like this, knowing that they are complementary. So think about that. If I have 0.3 plus the probability of B is equal to 1, well, what's going to add up to 1 there to make it complementary? You can think about doing algebra if you want and do some rearranging. But basically, the probability of B is going to be equal to 1 minus 0.3. or 0.7. And this can be handy for us because sometimes it's a lot easier to calculate the probability of something not happening, like the probability of the complement, than it is to calculate the probability that something does happen. If the probability of seeing a dolphin in Akaroa, or when an Akaroa is 15%, what is the probability of not seeing a dolphin? So this would be the probability of seeing a dolphin is equal to, change it to a decimal. And so the probability of not seeing a dolphin, assuming that they're complementary here, because you're either going to see a dolphin or you're not going to see a dolphin, would be probability of not seeing a dolphin would be 1 minus 0.15 or 0.85 or 85%. So here again we assume complementary, that you're either going to see a dolphin or you won't. So if you add the two together, it covers all the possibilities and you get 1. and from there you can work out backwards what you need to get.